Welcome to the second part of a mini course on working with Mograph-style animation in Houdini. Based on the principles from the previous lesson, we will continue adding layers and elements to our animations. We focus solely on the principles and techniques, and so far we are not touching the look or pretending to finalize anything. This is just a still flipbook render. Nevertheless, I'm sure you'll learn many tricks and techniques that will open up some new possibilities for your animation projects in Houdini. So let's get started. So let's pick up where we left off. I've slightly changed the length of the line. I've changed some parameters on resample, so less segments. But one issue though, all our stems for our future alien flowers looking at the same direction. So we about to fix this. Let's start with demonstrating the principle behind this. As you remember, in wrangle we have vector n, which set to x-axis and which defines the direction in which we have our curling. So to illustrate the concept, I will start with initialize n vector, and I will set it as an attribute. So I can do it like this. Right now we have normals facing x direction. To rotate it, I prefer using qRotate function. Basically, I will rotate the vector using quaternion. Let's start with defining our quaternion. We don't have to go into the technical details of this. One thing that we know is to define quaternion. We should use function called quaternion, and this function has two forms, and we will use the classical one. So first argument in this case would be the amount in which we need to rotate, so angle in which we need to rotate our quaternion. So let's start with creating just a channel, and it will be just a rotation. And we will fit this to radians function to get radians and to manipulate degrees. So let's set this to y-axis, and let's set our normal to qRotate. And the first argument of this function would be the quaternion, which in our case is rot. And second one would be the vector which we want to rotate. So let's see what it will give us. I will create the parameter. And basically, yeah, I have my rotation. So using this knowledge, let's go to our rig attribute wrangle and quickly set what we want. So we want to set this vector n. Let's start with creating random rotation angle, because we need random rotation for each primitive. So as a first argument, we will use primnum. As a second, as before, we will use seed, and we will add some figure to it. This is our first layer. Then we will reassign this random rotation to fit 0, 1 from the variable itself, which in our case random rotation. And we will use two channels, random rotation min and channel, let's close it right away, random rotation max, close parentheses. Then we will initialize value that will hold the final rotation, final amount. Let's call it rotation amount. And here we will use radians. We will create additional channel, which will hold our amount itself, like our base amount. And we will add our calculated random rotation to it. And then finally, from this, we will get our vector 4. It would be the quaternion, and it will be equal, as we discussed before, angle, which in our case, random amount, and the axis around which it will revolve. It will be y-axis as before. And then finally, we reassign our n vector to qRotate, rotation as an quaternion here, and n as a vector. Let's see what it will give us. Let's do something like this. And let's look at what we have initially. Let's increase the amounts. And as you can see, we can go both directions, which is what we need. So now when we have some visual interest for initial state, we can move on with the flowers itself. From attribute promote, when we set our p-scale, we will add carve node. Probably it's good idea to create here null and call it curves out. And in carve node, I need to extract tips. So I will set first hue to 1, and I will set radio button here to extract. And now we have our tips. Let's create something that will help us observe the rotation which we will have on these points. So I will create a tube and I will set one of the radiuses to 0. It doesn't matter which one you will choose. Basically, I just need to clearly identify the rotation because we will work on that for a while. So we will use copy to points, and right away we can see that we have inherited the p-scale from curves itself, so from this point. And because we set the ramp in sweep node itself, initial scale won't be affected. So we have good starting point with our scale. We can randomize it, of course. Attribute randomize. We will type p-scale in attribute name. Points is fine. We will have only one dimension. We will set it to custom ramp and we will fit values to some value. Right now we don't have any inherited rotation from curves itself. So let's add one. Before carve node, I will create node called orientation along curve. And right away we have something happening. And first issue that we have, besides the fact that we have wrong orientation or unpredictable orientation, you see this strange popping at some points. This because the orient along curve node doesn't have enough information to correctly perform the calculations. There is a solution which will work in this particular case. This is not an ultimate solution, but we can simply add transform node on our curves, offset it in some direction, for example X in this case, and fit this to second input of orient along curve. And this additional curves will say the orientation along curve node in which direction it should look preferably. And that way, when we have our animation, we no longer have this weird popping effect. And one last thing that left to be fixed is in our case, I think it's pitch probably. Yes, in this case, it's pitch and we will set it to 90 degrees. I don't want to set it in template geometry itself because I want to stay consistent and have predictable results. I don't want to offset this in some weird angles. Let's add node called match size to correct our pivot point on the prototype mesh. And now we have our copies at the tips of the curves. Next, let's work on animation, reveal animation of the flowers. Because using carve node, we have kept a lot of attributes from initial geometry, and one of them is our pure unremapped anim attribute right from the start, right from rig attribute wrangle here. So this will work in conjunction with existing animation. So we will remap it. On top of that, we probably can use just attribute wrangle for this, and we will remap anim. Let's start with that. We'll create tramp called remap animation. Second argument is anim itself, so anim attribute, and this will be p-scale multiplied equals this new channel ramp. Right now we have everything disappeared, and that's because we didn't create our ramp interface. Let's correct this to B-spline, and let's adjust animation. So right now we have inherited anim attribute, but with separate remapping. We can do whatever we want, something like a stairs. Here some overshoot. It's easily adjustable, of course. Let's do something like this. Let's see what will happen. So yeah, we have some additional movement, which is great. We can always go back to it. Right now it's fine as it is. Let's call it pscale anim, and let's work on color. First, let's start with the stems. We can go two ways. We can create connectivity attribute to separate this, but what I like more is to have some attribute right at the start, for example here, that will be passed along our branch. We will create ID attribute on points on which we copy our lines. And now we have simply just stored points initial ptnum. And we carry it over through the branch, through the graph. And as you can see on sweep node, we still have it, which is exactly what we need. Let's turn off lighting temporarily and let's use attribute randomize. Let's start with the CD. Right now you can see that every point here has random color value, which is not what we need. We will use the ID attribute as a seed attribute here to stabilize this. Right now we have this value, which is index and the global seed as a combined seed in this case. So this is pretty easy and fast way to get separate seed core set of connected faces without using connectivity node. And instead of using the CD attribute, we will create something like color mask attribute. We will set dimensions to 1 and let's create actual color node and we will use ramp from attribute. Outputs the value between 0 and 1. We can easily remap it. So let's use color mask here. And you can see that we have different colors and we can set it to something interesting. Let's add just a slight variation on the colors. So now we have the stems working, initially working. And let's color the points here. I will copy this attribute randomize, disable the seed attribute, because right now it's fine to have different color on each point, and I will copy this color. But I will choose some different values for this. So right now I'm just guessing, but I know that I want some of them to be bright, some of them to be slightly darker, some of them could be kind of like this. We can also animate color, but let's add final element after which we can just fine tune things is the light streak on the stems. Let's work on the curve itself. Let's add attribute wrangle. Probably here I can paste the color before the sweep node. It would be faster and the result would be the same because we have our ID attribute on curves also. So let's start with remapping the curve view attribute. We have our initial color. So let's call the curve view attribute. We'll place it in shrump. Let's call it light streak curve view and cd equal shrump light streak. Right now it's all dark, kind of like this. We will multiply it, or not multiply, but plus. Let's correct the shape of this light streak and we want to start it slightly above visible place. So let's your view and let's add here channel called streak offset. Unfortunately, this is kind of semi-procedural because based on this light streak, we need to utilize this attribute. We actually can get this value from the ramp, but this is not worth it for now. So let's do something like this. But we actually want to animate this. And as you can guess, because this value is from 0 to 1 and Trump also understands the values from 0 to 1, everything that doesn't fit this range will get clamped. And that's why we can kind of manipulate this. And worth mentioning that the behavior of this Trump has changed after version 18.5, I assume. Let's actually create new variable because it deserves it. Load anim. It would be equal Trump remap anim, and the source attribute would be anim, the same one that we used before. And let's correct this to B-spline and do something interesting. For example, make it like this. And probably it's better to have this in fit 0, 1. And the minimum value would be channel streak offset, and second one would be streak overshoot, for example, to control where it will end. So let's see what we have. Some reason we don't have any movement. Why? Okay, this because the fact that this latest Trump should receive also any variable here. I'm sorry. Let's see what we have here. This is completely the opposite of what we need. Let's adjust it. Probably minus anim. Let's try this. Yes, minus anim in this case. And streak offset be minus 0.3. Nice, it worked. And the nice thing that this is worked with the rest of our elements. So we can combine it, fine tune it. Instead of this tube, we can use spheres. We can also match size it. And probably it's a good idea to pack this before copy to points. And for example, we can have switch here. Let's turn on the lights. Should be like that. And in this color animation here, light streak, let's actually increase the brightness a lot. But also what we can do, we can sample the color from these points, set it to the second input of light streak wrangle, and we will multiply this tramp to color from the first input. So let's create vector color, and it would be equal point from the second input, and attribute that we need is CD, and the number of point would be primnum. So it's kind of opposite to what we did before. And let's multiply this by color. Let's see what we will get from that. And as you can see, now we have matching colors. We can multiply it to something brighter to emphasize this. Let's make the stems thinner by going to attribute randomize, make it even thinner. Let's make it taller also. We can make light streak animation be faster. And even at this moment, when we control the spheres or any other attribute, because of the way we have set this up, everything updating in almost real time. without simulation and stuff. We can change the size of the circle, and we can do all sorts of things. So for example, here I can increase amplitude, can reduce element size, make more of a breakup, make the outer stems shorter, correct the look of it, add more randomization to time using the second attribute noise. And at the end, we have pretty organic feeling, interesting reveal animation, which we can easily edit. I hope this mini course was useful for you. We broke down the basic principles of procedural animation in Mograph-style, namely the control of a large number of linked elements with infinite potential for complexity. And all those animation we have customized will react to changes in time parameters. With the help of attributes, we can control the order, randomness, and overall character of the animation. Since we are in Houdini, this control is not limited to position and rotation and scale, but extends to almost any property. Thank you for watching. See you in the next videos.